Okay. Good afternoon and welcome to lecture number 10, Mechatronics. We are going to see some multiple choice questions in this lecture, and we are going to solve some numericals also, which will be helpful in your final examinations. Okay. So we are going to discuss some tricks regarding block diagram reduction examples, because the examples are very, you can say, lengthier. How to convert them in smaller steps that we are going to see in last session. As you know, my name is Sachin Tolkar. Now we'll see first example, our first question. Which terminology deals with the excitation or stimulus applied to the system from an external source for generation of output? Okay. So the terminology or stimulus applied to the excitation or stimulus applied to the system from external source. We call it as input signal. We know that if there is any excitation in that system, it is input signal for that system. So the question is heavy, but the answer is very easy: input signal. Now the next question is, which among the following represent an illustration of closed loop system? So automatic wave washing machine, automatic electric iron, bread toaster, or electric hand dryer. Now you'll see all the examples are similar to each other, but in which you will get the closed loop system, that is only automatic electric iron, because in automatic electric iron only there will be feedback of temperature. In washing machine there is no feedback of your there are presets, so there is no feedback loop. In bread toaster also there is only timer setting and the bread will come out of the toaster. Electric hand dryer also, at when you are applying there is no feedback. That's why only one which is having closed loop system or feedback system is called as, that's automatic electric iron. Getting? A third, the output signal is feedback at the input side from which point? That is called as summing point, differential point, take-up point, all of above. So output signal feedback is came from take-up point that we know. So we call that point as take-up point only. In a parallel combination, the direction of flow of signals through blocks in parallel must resemble to the main, forward, feedback, opposite, or diagonal. So read the question properly again. In a parallel combination, the direction of flow of signal through blocks in parallel must resemble to the main forward function. Okay. So that is the answer. Main forward function, all parallel blocks should be in main forward function direction. An automatic toaster is just now we have discussed, it is a open loop system. So the answer will be your first answer, open loop system. Because in toaster there is time, you can say time constraint is there, and it has been pre-feed time. So that's why there is no feedback of that particular element. Transfer function of system is used to calculate which of the following: the order of the system, the time constant, the output of any given input, or the steady state gain. The answer, we know that transfer function is used for output of any given input system. Okay, so the answer is C, the output for any given input. The overall transfer function of two blocks in parallel are, two blocks in parallel, we have to sum. Okay, the first answer is correct. Sum of individual gain, that is the final answer. But you have to remember what is the actual question. The overall transfer function of two blocks in parallel. If it is in series, it will be product of individual gain. Okay, so that we have to remember. The transfer function is applicable to which of the following? linear and time invariant system, linear and time variant system, linear system, and non-linear system. Now here, first and second, if you'll see, there is only one word difference, that is time variant or time invariant. We know that we use Laplace transform, and Laplace transform is only used in time invariant systems. So the answer is linear and time invariant systems. Getting? Now the next. A finite number of blocks in series can be algebraically combined by blocks in series. So it is, answer is multiplication. We know that, we have just seen. Blocks in series will be multiplied with each other, or the gains of blocks will be multiplied with each other. The Laplace transform transforms differential equations into more easily solvable algebraic equations, convert time domain into domain of complex number, converts time domain into frequency domain, all of above. The first answer is correct, into more easily solvable algebraic equations. We have seen in M3, or maybe in this semester only, your maths 3, there is Laplace transform is there, second unit. If a system is with multiple inputs, its single output is a product of individual response, is sum of individual response, cannot be arrived at transfer function, or in is not similar to superposition theorem of electrical circuits. So actually I have not taught this, but you have to remember that if system is with multiple inputs, then what we have to do? We have to consider one input at a time. Okay. We have to consider one input at a time and calculate its transfer function. And then the answer is the sum of all the responses. If we'll add, then you will get the output of that particular system. So what we have to do in multiple input and multiple output system, MIMO system, or multiple input single output system, we have to consider one input at a time, considering all other inputs 0, calculate the transfer function, and then add all the sum of individual responses. That will be your final answer. Actually, in your syllabus, there is single input and single output system only, but maybe in multiple choice, this question will be asked. Requirements of control system is or are, what are the requirements? Stability, accuracy, speed of response, or all of above. We know that for control system, all of above are required. Maybe in first unit also I have taken this question. By mistake, it is again repeated, but it is useful for you. Requirements of control systems are all of above. Stability, accuracy, as well as speed is also required. Now, they may ask you this type of diagrams, and they will ask you to calculate the output of these diagrams. And you can calculate the output with the help of, you can say directly or with slight pencil work, you can calculate this. You'll get to know that this is G1 multiplied by G2. This H1 will be in feedback. So the answer of this loop will be G1, G2 divided by 1. Here it is minus sign, so plus G1, G2, H1. And again, H2 is in feedback. So we have to again solve it for that feedback. So the answer will be like this. So the answer will be G1, G2 divided by G1, G2 into bracket H1 plus H2 plus 1. Now, how to arrive at this directly? You can see here H1 and H2 both are in parallel. So you can add H1 and H2 directly. So you'll get in bracket H1 plus H2, and 1, both are having negative signs. So we can write 1 plus G1, G2 into bracket H1 plus H2. So this is small trick. We have to remember that if there are more than 2 feedback loops in parallel, you can add them directly, and you can treat them as a single entity. So this is one trick. Now again, we are going to see 2-3 examples, tricky examples, which we have, you can say I have written in my blog also. Some notes are there. So I'm taking some snapshot of from that notes. So determine the transfer function of the system shown in figure. Maybe they will not ask you a value of G and H, they will not give you. They directly will give some numerators to you, 1.5, 2, etc. So in that case also, you don't have to bother about that things. You have to directly multiply or add these things. Now, you know, this is step one. These two are in parallel. So their simple addition will be there. So feed forward path or parallel blocks are there. So 2 plus 1.5, it will be 3.5. Now again 3.5 and 10, it will be in cascading blocks. So answer will be 3.5 into 10, that is 35. And 35, and this 0.1 is in feedback. So it will be 35, and this 0.1 has feedback. So it is 35 divided by 1 plus 35 into 0.1. This is simple thing. So this negative sign, so that's why it is positive here. And if we simplify it, the answer will be 7.77. So your multiple choice question may have this type of diagrams, and they will give you the answers, different answers. So you have to use calculators for calculating that particular answer. Pencil and calculator you have to use, so that you have to remember. So transfer function of this particular diagram will be 7.77. Okay. Similarly, this example is there. If we'll see, this G1 multiplied by G2 is there. So it will be simple. There is a unity feedback here. They have not given anything. Only feedback loop is given. So I have written it 1. So it means it is a unity feedback system. So first step what we'll do? We'll do series blocks. That series block will be G1 multiplied by G2, and there is a feedback loop. So for feedback loop calculation, G1 into G2 divided by 1 plus G1 G2 into 1. As it is 1, so there is no effect on that particular entity. Now in third step, what will happen? You are going to add these two blocks because they are in parallel. So it is becoming G3 plus G4, and this G3 plus G4 will be multiplied with this because it is in series. Okay. Till this point, there is no any problem. Now you have to apply a feedback loop of H1S, and for that you will see here, that is G1 G2 into bracket G3 plus G4. I have not written yes here because for simplification, S is nothing but the domain, Laplace domain. So we can directly write G1 G2 also, divided by 1 plus G1 G2. So this is simplification, and H1. So in this, what we are going to do, we have to apply this feedback loop formula. This is minus sign, so we are going to take it plus. So 1 plus whole the numerator multiplied by HS, and this numerator will be as it is here. And after simplification, you will get this type of function. So you can simplify it on your own, because in multiple choice questions, this answer may not be there. So you have to simplify like what I have simplified here, and you have to arrive at this particular answer so that you will get correct choice, correct multiple choice. Okay, sorry. So next one, sometimes they may give you this type of numerical in which there will be values of GS. Now they will not specify you it is a value of GS. You have to read it carefully. A negative feedback closed loop system. Now first word, that is negative feedback. Closed loop system was subjected to 10 volt and the system has forward gain of 2. The what is this 10 volt? 10 volt is nothing but input signal. So it is RS. System has forward gain of 2. Forward gain. So GS is 2. The feedback gain of 0.5. 0.5. We know it is a negative feedback system. So your output CS must be equal to GS divided by 1 plus GSHS into input, that is RS, because this is transfer function CS upon RS. So if I'll take RS on this side, it will get multiplied. And if you know the formula, if you can arrive at this particular point, then you can easily find out the answer in one step. So 2 multiplied by 10 divided by 1 plus 2 into 0.5, it is divided by 2. So 10 volt. So input is 10 volt, output will be also 10 volt. Now what error can be there? So error upon output is nothing but 1 upon 1 plus GS into HS. This formula is given in notes. So you have to use this formula for error calculation also. And if we'll calculate with the help of the values, RS is 10, GS is 2, and HS is 0.5. You will get the value 5 volt as error. So they may ask you output or error. This type of examples you have to practice for final examination. Also, this is one trickier one question. It was asked for 8 marks in one of the INSEM examination. If you will see it properly, then you might get confused. So can they ask this type of question? But this is also very easy question. Only one trick is there. That trick is we are going to find out here. For simplification, we will take all takeoff point on the right side. This is one takeoff point. I'll just mark the takeoff points. Then you'll get to know. So this is one takeoff point. And this is second takeoff point. The second takeoff point is at the end. So there is no problem at all. We have to convert this takeoff point on this side. And all summing junctions, there are 2 summing junctions. This one is one summing junction. And this another one is one summing junction. If we'll shift all the summing junctions on left side and all takeoff points on the right side, then what will happen? We'll see. It's very simple, very easy to remember. When you are shifting summing junction on left side, you have to divide by the functions which are coming in between. When you have to shift this takeoff point on this side, you have to divide it by the function which is coming in between. So if we'll see the second diagram, this diagram, you will get to know this is converted H2 divided by G1, G4 because summing junction has been shifted here. So divided by G1. Summing, this takeoff point is shifted here. So it is divided by G4 also. This is one. All these will come in series G1, G2, G3, G4 because all points have been removed. H1 is shifted twice. So G1 and G2, H1 divided by G1 and G2. So this will be second feedback and third feedback is H3 as it is. Now, after simplification, you will get to know that these are all in series and these feedbacks are all in parallel. So we have to use series and parallel rules only. And afterwards, we are going to use only one feedback loop. So this is the trick in this example. On next slide, you will get G1, G2, G3, G4 because it is in series and H3 plus H1 divided by G1, G2, H2 divided by G1, G4. This is in parallel. So they have been added. Now only we have to use this feedback rule and with the help of this feedback rule, G1, G2, G3, G4 divided by 1 plus G1, G2, G3, G4 multiplied by H3 plus H1 by G1, G2 plus H2, G1, G4. This is in bracket. And if we'll simplify it, If we'll multiply inside the bracket, what will happen? We'll see. It is G1, G2, G3, G4 into H3. If I'll multiply here, G1, G2 will get cancelled. G3, G4 into H1 and G2, G3 into H2. So this is the simplification. This was coming for 8 marks, but maybe they will ask this type of question for 2 marks, etc. in your this examination or maybe final examination. So you have to prepare like this. If the diagram is looking complicated, you have to remember that we can shift all the summing points on one side and all the take-up points on the other side for simplification. That we have to remember. So this is the only trick in this example that you have to remember. Okay, till the time, if you have any questions, you can ask me, and you can visit to this mechatronics blog for further study for all the, you can say, notes available there. I'm going to update the notes also, and maybe whenever there will be time, I'll issue you some multiple choice questions also. So this is Sachin Todkar signing out. Till we meet again in next lecture. Thank you.